Now this integral, we have an end, the natural number here. Seems that here we want to develop a formula. Okay, well, how about try this? This is equal to, well, this is a half sine 2x, isn't it? To the nth, yeah. Now we have a 2x here, so I want to change it dx into 2x. So therefore, to multiply by half. So keep equal sign there. And this one is equal to 2 n minus 1, right? Integral cosecant n of 2x d2x. Okay, so now we know that instead of integrating this, we are integrating this. So that means if you can integrate cosecant nth power, then we can integrate that, right? So it's not really a formula, but rather it tells you how to do it. Well, we do this one instead. We do that. We do cosecant. So let me try some integral get involved with the cosecant n. All right, start with when n equal to 1, n equal to 1 cosecant x dx. Then this one is equal to integral dx over sine x, isn't it? This one is equal to, if I multiply by sine on top, then I times sine at the bottom, right? This is sine square. So this one could be written as negative, right? Negative d cosine. And this would be 1 minus cosine square. Yeah. Then this way is equal to negative. This is a 1 plus cosine x plus b 1 minus cosine x and d cosine x. Well, it's a partial fractions, right? We can determine a and b. A and b here is half. So this is equal to negative 1/2. This would be log 1 plus cosine x minus, because there is a minus here, log 1 minus cosine x. Right? Well, then we combine them. This one goes negative, goes in, this is positive. Positive means on the top, right? This is equal to cosine 1 minus, this will be positive, right? This will be negative. 1 plus half means a square root, isn't it? Plus c. This will be equal to natural log square root. We multiply by 1 plus cosine. 1 minus cosine square on top and the bottom, and both times 1 minus cosine. So this is 1 minus cosine square. This will be 1 minus cosine square plus c. So this one is equal to, this will be sine square. This will be 1 minus cosine. So natural log 1 minus cosine. This will be sine plus c. So this means the natural log, I take absolute value. Then one of us sine is cosecant, and cosine is cotangent. So in other words, we have done that, right? So this is actually a basic formula. Now what I'm doing here is just derive the formula for cosecant. Okay, now let's do the cosecant square. See, what I'm doing here is just to show that how do we handle cosecant nth power, that function for integration. When n equal 2, well, that is easy, right? Simply means equal to negative cotangent x. So that is easy. Now, how about the 3? Cosecant cube x dx. Cosecant cube is equal to cosecant square times cosecant, right? So cosecant times cosecant square. Cosecant square is the derivative of cotangent, but negative. Okay, that's correct. Yeah. So this means we can use by parts, u dv, right? This is a negative cosecant x cotangent x minus become plus vdu. This one times this derivative. This is cotangent times this derivative. This one is negative cosecant cotangent. So cotangent square cosecant dx. Right? Good. Then this one equal negative cosecant x cotangent x minus, this is a cosecant square plus 1 times cosecant dx. So we have a minus cosecant x cotangent x minus this one times this one is a cosecant cube x dx. Cotangent square, this is a minus, right? Minus. Sorry, this is become plus cosecant x dx. Yeah, so we move this one over there, so you get 2 cosecant cube. So cosecant cube x is equal to 1/2 this, right? Negative cosecant x cotangent x plus this. This is equal to that, right? Plus natural log cosecant x minus cotangent x Yeah, plus c. Okay, so we have done this. And next one is cosecant of fourth. Cosecant fourth x dx. Now, that one, even number is easier. Even number is equal to, this one is a cosecant square times cosecant square. Cosecant square is cotangent to square plus 1. That is a cosecant square. The other one, the other cosecant square become this. The derivative of cotangent is a negative, right? Negative. So they're equal. So this one equal to negative. This will be negative 1/3, cotangent cube, and minus cotangent x, yeah, plus c. Okay. Next one is a cosecant fifth power dx. Well, that one is equal to cosecant cube times cosecant square, right? Yeah. And this one is equal to by parts. If you create, well, I create this one as a cosecant cube. I try to use by parts. Therefore, this becomes derivative cotangent x, right? But negative. Leave negative outside. Okay, so this one goes to negative cotangent x cosecant cube x uv, right? Minus v du. This one times the derivative of this one is 3 cosecant square x times the derivative of cosecant, which is negative cosecant cotangent and dx. Right? So this one is equal to negative cotangent cosecant cube. I bring negative outside. This one will be cosecant square times cosecant cube. Cotangent times cotangent is cotangent square. I'll take 3 out. 3 is there. And cotangent is a cosecant minus 1, right? Cosecant square. So dx. Yeah, that's better. So this one is equal to negative cotangent x cosecant cube x minus 3. This time this one becomes cosecant fifth. This one times this one plus 3. The integral cosecant cube x dx. Well, we move this one over there, right? This is a cosecant. So over there is equals 4. Therefore, cosecant fifth power is equal to 1 over 4 multiplied by this. Cotangent x cosecant cube x plus 3 times this. Cosecant cube. We have done it. That is the result, right? That is the cosecant cube. So we put it here. Okay. So that is a cosecant fifth. This is a cosecant. Now then, cosecant 6. Cosecant 6. When you have even number, it's very easy. So this one is equal to cosecant fourth times cosecant square, right? So this one is equal to cosecant the fourth is what? Cosecant the fourth is a cotangent square plus 1 square, right? Yeah, this is cos, and this one is a derivative cotangent negative. So this one is equal to negative cotangent fourth x d cotangent. Yeah, plus 2. Yeah, 2 cotangent square x d cotangent. And the last one is minus d cotangent x. So at the end, well, we have this, right? Negative 1 over 5 cotangent fifth plus minus 2 over 3 cotangent cube x and the minus cotangent x plus. Okay, so when you have an even number, now okay, let me summarize here. When we are dealing this integral, when you have even numbers here, it's very easy, you know, as done as as I have as I have done here. When you get odd numbers, always doing things like this. You need if this is a 5, then you need a 3. You need a 3. If this is 3, you need the cosecant first. If this is 7, you need a previous result of fifth power of a cosecant. If this is 9, then you need a cosecant of seventh power integral. So when we are there, okay, what I what I'm doing here is that we can do this integral. We can do this integral for whatever n is. N is a natural number, right? So we can do that. So this is this. This we can do, you know, as I've done. Okay, this is just one way because let me. Okay, right. How should I say? Now we are dealing with this integral actually. To do this integral, we are doing this. This is just one way. For specific n, when you're given, we can do different methods. Well, maybe there are different methods. Let me. Okay, I'll try one by one. Okay. How about this? N equal to 1. N equal to 1. Huh? N equal to 1 is sine x cosine x dx. Of course, we can do this way, okay? But also we can do different ways. We we can treat this integral differently. Now, how about this? We divide by cosine square x, 1 over cosine square x, sine x, cosine x. Then this will be, on top will be secant square. Secant square is the derivative of tangent. And this cosine cancel out, the other cosine makes cosine, and the sine is a tangent. So that one is log tangent. See? So we can do this one by using this method. In addition to this method. The answer may be different form. It doesn't matter because the antiderivative could be in different forms. Okay. Now how about n equal 2? N equal 2, that would be dx sine square x cosine square x. Okay. And of course we can do this integral by using this method. We can do cosecant square. But in addition to that, we can treat it differently. We can do a different way. So how about this? 1 is equal to sine square plus cosine square dx. This is sine square cosine square. So this one equal to 1 over cosine, right? Plus 1 over sine. 1 over sine square. Well, 1 over cosine is what? 1 over cosine is secant, right? And secant integral is tangent. 1 over sine is a cosecant. Cosecant square integral is equal to negative cotangent. Right? You see, we can do this one nicely. Of course, you can do this way, right? The answer might be different form, doesn't matter, because antiderivative could be in different forms. Now, how about 3? N equal to 3. N equals 3 would be this, right? dx sine cube x cosine cube x. Yeah. What to do? Now, how about this? How about that? We just find a way to integrate beside this method, right? In addition to this method. Now, how about this? This is equal to sine cube cosine cube. How about sine square x plus cosine square x and a square? Okay, this is 1. 1 square is 1. So this one becomes a what? This becomes a sine fourth plus cosine fourth plus 2 sine square cosine square. And the sine cube x cosine. Yeah. Now then we have three fractions, right? The first one, this over that, it becomes a sine. This is cancel out, and this is a cosine q dx. This second one will be cosine one cosine left, and sine cube x, right? And plus 2 dx sine x cosine x. Yeah. And this one is easy. This one is a cosine q. This is a d cosine, which is negative. Plus, this is a sine. This is a d cosine. D sine, sorry. D sine x. This we have done is 2 log up tangent x. Okay. So this one is easy. This can be done nicely, right? This becomes 2 cosine square x. This can be done nicely. This is 2 plus 2 log tangent x. Right? So it's been done. If we can simplify. This is 1/2 secant, right? Square x minus 1/2 cosecant square x plus 2 log tangent x. Let's see. So we have done this integral. We didn't use the formula cosecant cube. You see. Now, how about n equal to 4? So this will be dn sine 4th x cosine 4th x. Yes. Not using this formula, okay? We could do this one for any n, right? By using cosecant. But as I said, we might have other ways beside this cosecant. Now, how about this one? This well, we could do this one as this way, right? Secant square plus cosecant cosine square dx, and the sine 4th cosine 4th, right? So this one becomes it will be equal to the first term sine 4th. Cancel out, becomes dx cosine 4th x, right? Plus this over that one becomes dx cosine 4th x, yeah, plus 2 to this one is equal to dx sine square x cosine square x. Yeah, they're easy. This one is a secant 4th x, right? This is the cosecant. Cosecant fourth x dx. This one minus 2. Well, we have done it, right? This is cotangent minus cotangent. Tangent minus become plus cotangent plus c. Okay, so it's been done. Yeah. Well, we sometimes we have more than just one method. We can do something differently. For example, for this one, this is dx sine fourth x. Sometimes we have more than one method to do it. This is one of them, and using formula is the other. Using formula is the other one, and this is also a method. We can do this differently. How about we divide by 1 over cosine eighth. So we divide by cosine eighth. This is a sine fourth cosine fourth x. Then the denominator, this cancel with that one. You have a cosine fourth becomes tangent fourth, right? And the numerator, this is a cosecant. This is secant eighth. Secant eighth is a secant 6 times secant square. Secant square is 10. This is a tangent, right? This is a tangent cosecant. This is secant square. I'm sorry. This is secant square. This is a secant eighth. Therefore, there are another secant 6. Secant 6 is tangent square plus 1 to the cube. That's tangent. This is secant 6. So it can be done nicely. Here, this one is equal to, well, not jumping, okay, tangent fourth x. This will be tangent 6, right, plus 3 tangent fourth plus 3 tangent square plus 1 d tangent. So this one over this one square, tangent square integral is equal to 1/3 tangent cube, right? That is for this one. Now the next one is plus, this is cancel out, 3 tangent. This, you have a 3 out, right? This is tangent square. Now, 1 over tangent square is 1 over tangent, right? Yeah. So that one is minus 1/3 tangent cube x plus c. Yeah, of course we can do some simplification, but anyhow, the integral has been done. See, which is a method additional to this one and additional to this one. So here I'm just show the variety of the methods of the same integral. Now, how about next one is fifth, dx sine fifth cosine fifth. Okay. Well, how about this? How about this method? We do this sine fifth, cosine fifth. This is sine square plus cosine square. That's 1, right? To the cube dx. So this one equal to sine fifth, cosine fifth x. This will be sine 6, right? This is plus 3 sine fourth cosine square plus 3 sine square cosine fourth plus cosine 6 x dx here. So we can simplify each term, right? Yeah. So the first one is the first cancel is sine x dx, right? Cancel this is cosine 5. And the last one, let me do the last one first. The last one will be cosine dx and the sine fifth x. Now these two terms, there's a common factor, 3 out. Sine cosine square, sine square, cosine square is common factor. Left is cosine, left is sine plus cosine. Sine square plus cosine square dx over sine 5 cosine 5. Well, this could be done as a negative d cosine, right? And the cosine 5 plus d sine. This is sine 5 plus 3. This is 1. This reduced is d sine q, cosine q. So that can be done nicely. This becomes 1 over 4 cosine 4, right? This is done as 1 over 4 sine 4th x. This has been done before. Yeah, this has been done. So, yeah, this has been done. Okay. So we have done fifth. Well, what I'm doing today is just demonstrate. See, when you do integral, you have choices of methods. If you're very good at those basic stuff. Let me do one more. One more cosine. This should be the last one because you can develop yourself, right? If this is a dx sine 6x cosine 6x. Now, yeah, we can do this by using this method, right? There's 2 to the 5th power, cosecant 6 2x d2x. That is one way. Now we can do other ways. Yes, there might be more than one. Might be more than two or three methods. So this is one. This is one method. Sine square x plus cosine square x cube. That's one. This is one. This is sine 6 plus cosine 6, right? So they're equal. See, techniques of integration is nothing but changing integrand at the same time maintain equal sign. That is called technique. Now this is equal to integral. The first one is sine 6, right? Yeah, yeah, plus 3 sine 4th x cosine square plus 3 sine square cosine 4th x plus cosine 6x dx over sine x cosine 6. Okay? Yeah, let's do the first one. This one cancels with that one. That is dx over cosine 6. Okay, that is this one. Okay, this one over that. And the last one, this over that, becomes dx, cancel out, this is sine 6. And the midterms common factor is 3. And sine square, cosine square is common. Left over sine square plus cosine square, right? And sine 6 cosine 6 and dx. Well, this one is secant 6, right? This is cosecant 6. This is a 3. This is a 1. This is reduced. This is dx over sine 4th and cosine 4th, right? So this can be done. This can be done as this. We just did it, right? So that has been done. That's been done additional to this method. See, this is what. Okay, let me summarize. Okay, we are given this integral. We could we could do this way, and we can do other choices when n is a specific value. Okay. Well, what I'm doing today is a very good exercise. I recommend you do by yourself. Through those different ends, different methods. It is really, really good to improve your integration techniques. Sometimes I told my students, well, you have learned many years of math, primary school, high school, college. You have learned arithmetics, algebra, factorization, equation solving, functions, and derivatives, and those basic rules, quotient rule, chain rule, product rule, and so on. Now you come to integration. You need them all. You need everything you learned before. So anything weak, any any weakness you have before, you have problem integrations. While if you're good at everything you've learned before, you just play game here, You can do all sorts of different integrals. You need all the knowledges you have learned before. Well, today is a little longer, but I hope you like it. Thank you.